This video is all about the periodic table. This is the periodic table that is pictured in your book on page 50. Let's look at some very specific things about this periodic table. One, you will notice, is that there are numbers 1, 2, 3, 4, 5, 6, etc., all the way up to 18. All these numbers are numbering columns, up and down groups on the periodic table. Now, columns on the periodic table have a name. The name of a column in the periodic table is a group. That's also called a family. Okay, that's a column. The reason it's called that is because the properties of the elements in a group are very similar. Okay, that's why they call it a family. And they are numbered across from 1 to 18. There is actually another numbering system where these tall columns are numbered with A's, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, and these lower columns here are numbered with B's. But for the most part, we're going to be talking about 1, 2, 3, 4, 5, 6, 7, etc. Now, across, you will note there are also numbers. These numbers are numbering rows. A row on a periodic table is called a period. Hence the phrase periodic table. What happens in a period is that the elements' properties change periodically. They change in a regular pattern, and then they repeat. So the properties actually change as I go across, and then when I get back to here, that same pattern repeats itself. That's why the periodic table is called the periodic table. Now, this particular periodic table on page 50 on your book is color-coded for the main groups of things on the periodic table. This tannish color here, as you'll see by the key here, is called the metals. Okay? These are the metals. The greenish ones here, those are the non-metals. And these bluish ones, those are the metalloids. So you'll notice the vast majority of elements on the periodic table are metals. Some of them over here are nonmetals, and the ones in between are metalloids. See this jaggedy line there? That's the line between metals and nonmetals. Now let's talk properties. Metals are, for the most part, solid. There is, in fact, only one non-solid among the metals, and that is mercury. This guy right there, that's a liquid at room temperature. But everything else among the metals is a solid under normal conditions, room temperature, room pressure. They are good conductors of heat and electricity. That's why all your pans, for example, your aluminum foil, your copper pots, those are all made of metals because they're good conductors of heat and electricity. They have very high melting and boiling points, hence why they're solids. They are malleable, which means you can mold them into shapes. They are ductile, which means you can pull them out into wire, like, for example, the electrical wiring in your house. All of those things are properties of metals. Now, nonmetals are pretty much the opposite. Nonmetals are, lots of them are gases. Not all of them by any means, but a lot of them are gases. Look at the periodic table in the room 349 in the chem room. That is actually color-coded by whether it's a gas or a solid or a liquid at room temperature. The only one of the nonmetals that's a liquid is bromine right there. All of these guys are gases. These two are gases here, gases. Okay, there's a few solids, but a lot of them are gases. If they are solids, they're brittle, not ductile, not malleable. They fall apart. Think of the graphite in your pencil. That's carbon. That's a nonmetal. Brittle. They are poor conductors of heat and electricity. That's why when you stir your soup on the stove, you use a wooden spoon, because then your spoon doesn't get hot. And they have low melting and boiling points. Now what about metalloids? Metalloids are actually in between the two. Nature doesn't suddenly go, oh wait, stop, I've stopped making metals, I'm going to start making nonmetals now. It has these little transitions. Okay. And really the properties of metalloids are kind of halfway between those of metals and nonmetals. They are semiconductors, for example. Okay, now, here's another picture of the periodic table. What we are going to talk about now is some areas of the periodic table that have names to them. The first column on the periodic table is actually called the alkali metals. Alkali metals, A-L-K-A-L-I, metals. That's the first column. The second column on the periodic table, those are called alkaline earth metals. Don't get those mixed up. These guys on the group 1 are the alkali metals. Group 2 are the alkaline earth metals. Alkaline earth metals. Alkali metals are very, very reactive. Okay? Very reactive. Hydrogen actually doesn't count as an alkali metal, but I'm going to put it up there for reasons I will get into later. Alkali metals are very, very reactive. Alkaline earth metals are also reactive, but not as much as the alkali metals. Over here on the other side, this last column here, column 18, those are the noble gases. N-O-B-L-E, the noble gases. Noble gases are not reactive at all. They don't react with anything. Not spontaneously, anyway. In fact, that's why they're called that. The noble gases, they don't associate with the peasantry, you know. That's exactly why they're called the noble gases. They're also called the inert gases. These guys right next to the noble gases, fluorine, chlorine, bromine, iodine, astatine, those guys, those are in fact called the halogens, H-A-L-O-G-E-N-S, the halogens. And the halogens are very, very reactive. These guys here in the middle, this lower area in the middle, those are called transition metals. These are the ones that are not very reactive at all. If you look here, these are your coinage metals. Nickel, silver, gold, copper, platinum. These things don't react very much at all. Okay, so the next thing I want to talk about is charges. Remember in the last video, I talked about protons, neutrons, and electrons. So, for example, hydrogen here has 3 naturally occurring isotopes. One that has 1 proton and 0 neutrons, one that has 1 proton and 1 neutron, one that has 1 proton and 2 neutrons. Those are all isotopes of each other. So there are different atoms of the same element with different neutrons. But don't think about them as if one turns into another. That's not what happens. There just happens to exist certain atoms that have different neutrons, even though they have the same number of protons. So protons, that never changes. If an atom has 1 proton, it's hydrogen, no matter what. That's what we said that's what these giant numbers are here. Those are the numbers of protons. Now the other thing we said was that the number of electrons is always the same as the number of protons. That's true for a neutral atom. But atoms can gain or lose electrons. Those are called ions. Ions are charged particles. Charged particles. Okay? They're atoms that have either lost or gained an electron. Now think about that. If the protons and the electrons are exactly the same number, and they have the same charge but opposite, if electrons are gained or lost, then there will be a charge on the atom and it becomes an ion. Now think about this for a minute. If you have an atom that has one proton and one electron, and that electron gets lost, all you have left is that one proton. You have a positively charged atom, ion. You have a positively charged ion, and it's got a charge of +1. If I have an atom with 2 protons and 2 electrons, and both of those electrons go missing, I have a charge of 2+. Okay, so losing electrons gives me a positive charge. Okay, it's backwards, so don't forget that. Losing electrons gives you a positively charged ion. By the way, there's a name for positively charged ions. It's called a cation. That is not pronounced cation. It is pronounced cation. Positively charged ions. Atoms could also gain electrons. If I have my +1 hydrogen atom and I have 1 electron and another electron comes in from some other atom, now I have 2 electrons. Where I once had 1 and 1, I now have 1 and 2, so there's an extra negative there, and that's a -1 charge atom. So gaining electrons, negative charge. Gaining electrons, that's a negative charge. These are called anions. Okay, not anions. Anions, negatively charged ions. Let's practice a couple of those. Let's think about those nuclear symbols. Let's say I have oxygen, 816. This guy has 8 protons, 8 electrons, 8 neutrons. But if I write instead this, now I have 8 protons still. 16 minus 8, 8 neutrons still. But now I have 2 extra electrons, so I have 10 electrons. 2 extra. Don't let that minus sign fool you. It's kind of backwards because electrons are negative. So 8 protons, 8 neutrons, 10 electrons. If I have something like Cr3+, 24 here, 52 there, I still have 24 protons, 52 minus 24, 28 neutrons. How many electrons do I have? 3 positive charge. That doesn't mean I add 3 electrons. It means I have 3 more protons than I do electrons. So there's 21 electrons. Okay? Now, let's look at this periodic table again, because charges on the periodic table actually come in a pattern. The rule is everybody wants to be like a noble gas. We'll talk more about where the electrons are around a nucleus later. But the important thing to know is these guys, the noble gases, they have what they call a filled shell. They have as many electrons as they want. So all the other atoms gain or lose electrons to be like the noble gases. So the alkali metals over here, in order for them to be like a noble gas, all they have to do is lose 1 electron. So if they lose 1 electron, and they all have a +1 charge. So all of these guys, the ion they most want to make is positive 1. That's why they stick the hydrogen there, even though it's a nonmetal and not really an alkali metal. It's because it wants to be a plus 1 charge. 99 times out of 100, hydrogen as an ion will be a plus 1 charge. And all of these guys, lithium, sodium, potassium, rubidium, cesium, francium, when they're ions, they're going to be a plus 1 charge. These guys here, the alkaline earth metals, to be like a noble gas, they want to lose 2 electrons. So they will all have a plus 2 charge when they become ions. That's what they want. They want to lose 2 electrons, and they will be a plus 2. These guys over here, halogens, their plan is to gain an electron. If they gain one, they'll be like the noble gases. So their charge is going to be minus 1. Okay, when those guys make ions, they're going to make a minus 1 ion. Now you'll notice at this point, this line is going to get in my way. So what I'm going to say for this, group 16, really only applies to the non-metals among them. Those guys, these non-metals, to be like a noble gas, they're going to gain 2, and they're going to be a minus 2 charge. They're going to gain 2 electrons and be a minus 2 charge. Group 15, the only one I'm really talking about here is nitrogen, though phosphorus a little, but for the most part nitrogen. If nitrogen becomes an ion, it's going to be a minus 3. That's the end of all the easy ones. So we will come back and talk about this a little bit more in the next section. But for the most part, this is what you want to know now. These guys, the alkali metals, plus 1 charge. These guys, the alkaline earths, plus 2. Halogens, minus 1. Basically, oxygen and sulfur, minus 2. Nitrogen, minus 3. And that's all because they're gaining and losing electrons to become ions.